NEC Article 460.54 addresses neutral conductors carrying current specifically in relation to medium voltage circuits. This section of the National Electrical Code prohibits the use of 600 volts neutrals in conjunction with medium voltage circuits, which are defined as circuits operating at over 600 volts. The primary reason for this prohibition is safety. Medium voltage systems have significantly higher potential for arc flash and other dangerous electrical phenomena compared to 600 volt systems. Combining a 600 volts neutral with a medium voltage system creates an unacceptable risk of equipment damage and personnel injury. The NEC is structured to ensure electrical installations are safe and reliable. One crucial aspect is properly managing neutral conductors, especially when dealing with different voltage levels. A neutral conductor is part of an alternating current, or AC, electrical system and provides a return path for current from the load back to the source. In a balanced three-phase system, the neutral conductor ideally carries minimal current. However, in real-world scenarios, imbalances in loads across the phases cause current to flow in the neutral. In single-phase systems, the neutral conductor carries the same current as the line conductor. Because the neutral conductor carries current, it must be properly sized to handle the expected load. The ampacity, or current carrying capacity, of the neutral conductor must be sufficient to prevent overheating and potential fire hazards. The NEC provides detailed tables and calculation methods for determining the appropriate conductor size based on the anticipated current and the conductor's insulation type and ambient temperature. Grounding is another critical aspect of electrical safety. Grounding provides a low impedance path for fault current to flow back to the source, which causes the overcurrent protective devices such as circuit breakers or fuses to trip, de-energizing the circuit and preventing electrical shock hazards. The grounding system consists of a grounding electrode, such as a ground rod or a metal water pipe, connected to the electrical system's neutral point and equipment grounding conductors. Equipment grounding conductors provide a path for fault current from the metal enclosures of electrical equipment back to the grounding system. This ensures that if a fault occurs within the equipment, the enclosure will not become energized, protecting people from electric shock. The NEC mandates specific requirements for grounding electrode systems, including the size and type of grounding electrodes, the methods for connecting them to the electrical system, and the maximum allowable resistance to ground. Proper grounding is essential for the safe operation of electrical systems. Article 250 within the NEC provides comprehensive guidelines for grounding and bonding. Bonding refers to the practice of connecting all metal parts of an electrical system together to create a common electrical potential. This helps to minimize voltage differences between different metal parts, reducing the risk of electric shock. Bonding also helps to provide a low impedance path for fault current, facilitating the operation of overcurrent protective devices. The NEC specifies requirements for bonding conductors, bonding jumpers, and bonding methods to ensure that all metal parts of an electrical system are effectively bonded together. When working with electrical systems, it is crucial to follow all applicable codes and standards. The NEC is the most widely adopted electrical code in the United States, and it provides a comprehensive set of rules for the safe installation and maintenance of electrical systems. Failure to comply with the NEC can result in serious electrical hazards, including electric shock, fire, and equipment damage. It is essential to consult the latest edition of the NEC and to seek guidance from qualified electrical professionals to ensure that all electrical work is performed in accordance with the code. In summary, the NEC prohibits the use of 600 volts neutrals with medium voltage circuits to ensure safety and prevent electrical hazards. This is explicitly stated in NEC Article 460.54. Always refer to the latest edition of the NEC and consult with qualified professionals when working with electrical systems. Understanding the specific requirements for neutral conductors, grounding, and bonding is essential for ensuring the safe and reliable operation of electrical installations.